All right, these are the practice problems. The first one, the directions on a lot of them, doesn't say simply find the missing sides. And what these questions are really asking you to do is to say, okay, what piece do I know, and do I need to multiply or do I need to divide to find it? So in this case, we know that we have a 10 on the hypotenuse. There we go. We have a 10 on the hypotenuse. And so when that happens, we simply say, okay, well, it's on the hypotenuse, and it's a 30, 60, 90, so I need to get that control piece first, right? Find the baby. Get that baby in control. So we have to take that 10 and divide it by 2 to find this x piece. So 10 divided by 2 is equal to x. So that means that the x is really 5. And once we have the baby, right? Once we have that baby piece, then we can start using multiplication to find the last piece that we're missing. So we'll do multiply, and we're getting the longer leg, so we need to multiply by the square root of 3. And when we do 5 times the square root of 3, it's nothing fancy. So some of these problems are going to be nothing fancy. I think the next one is another nothing fancy problem. Yep. So monk is a square. Find OK. Go ahead and push pause and give this one a try. This one's not 30, 60, 90. Hint, 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 hint. So if we know it's a square, then we're allowed to say that all 4 sides are the same. And if it's a square, then we know it's also a rhombus, which means that the diagonals have bisected those two. Right? That's that rhombus rule. And look, we just got a, oh, I forgot the right angle, didn't I? 45, 45, 90, didn't we? And hopefully you didn't need all that explanation. Hopefully that was just something you just simply knew. And if we know that the legs are each 9, then to find OK, remember to go from a leg to a hypotenuse, you use multiplication, right? Small to big. Something small getting bigger is always a multiply. So 9 root 2. So you have to be kind of cautious. There are only 2 angle measures in a 45, 45, 90. Yes, there are 3 angles, but there are only 2 angle measures. So the weird thing is that we would use a square root 2. In a 30, 60, 90, there are 3 different angles. So that's when we find that middle, that weird one is a root 3. Kind of awkward. All right, so we've done 2 easy ones. Now let's make them a little bit harder. Find the missing sides. I'm not going to leave you alone on this one. I think it's one we need to work all the way together. So the first thing I always do is I identify the baby of the family. Who's my control piece? And how do I get it? Right? It's like a bad Arnold Schwarzenegger joke. Who is your daddy and what does he do? Not a good joke teller, sorry. So we have the longest leg and we want to get to something smaller. So that means we need to divide. We definitely know it's a division because we want to get smaller. And going from the long leg to the baby is a divide by the square root of 3. For the first few of these, you might find you want to write the workout. It looks like this. 6 divided by the square root of 3. Now the rule of radicals, remember, is no radicals in the denominator. So now we need to rationalize the denominator. You're going to get to the point where you can do this in your head, but for our first time together, let's show all the steps. When we rationalize the denominator, that means we have to get the radical so it's not down there anymore. So we got the radical out of the denominator. So it's currently at square root 3. So I need to change it by multiplying by square root 3 under square root 3. I'm going to show all the algebra that happens because I know some of you like that. So across the top, 6 root 3 over, and those are both under the radical, so square root of 3 times 3 is 9. Getting closer. I ran out of space, so let me shoot down here. So the top we can't simplify. That's just 6 root 3. But the denominator, the square root of 9, is just 3. And the last step is always simplify the fraction. So 6 over 3 is going to become a 2, right? 2 over 1. So 2 root 3 over 1. And since it's my notes, I'm just going to go ahead and finish it up and say, well, we would never write a denominator of 1, right? 2 root 3 is my final answer. That's the length of this baby side. 2 root 3. Once we have the baby, then we can change, right? I changed colors, but you're actually going to change operations, because to go from the baby to the hypotenuse, right, from the littlest to the oldest is an easy jump. You have to do 2 root 3 times 2, right? And those are both outside, so we end up with 4 root 3 is the length of the hypotenuse. I'll put it over here. Now a 30, 60, 90 triangle is the only kind of triangle that has a relationship where the hypotenuse is twice the smallest leg. It's the only triangle, the only right triangle where that happens. It's the only place. Kind of cool, but it's a fact. So, let's try one more. I think this one I might let you try on your own. I think there's one more. Yep. Find the missing sides. Pause the video, come back and check it out. Alright, so here's the work to that problem. Remember that since we knew the hypotenuse, we have to use division to find our missing side, to make it smaller. And in this case, because it's a 45, 45, 90, right? Isosceles right triangle, we're going to divide by that square root 2 factor. So I wrote out my work, 4 divided by root 2, then I rationalized my denominator and simplified my fraction. I promise you're going to do enough of these that by the time you get to class on Monday and we can talk about these, you're not going to need my help with rationalizing a denominator. So since I knew it was isosceles, I just put both measurements on the triangle. I think that's my last practice problem. Let's check. Correct. It was my last practice problem. So I will see you in class on Monday, and I hope you have a fabulous weekend. See ya.